Functions, page 16. Consider the function 1/2 x minus 1. Find the inverse function. So remember, to find the inverse function, you need to do variable interchange. So you instead of doing y equals 1/2 x minus 1, you're going to do x equals 1/2 y minus 1. And then you're going to solve for y with algebra. Okay, I'll leave that for you. Then you're supposed to find f follows f inverse function, and f inverse function follows f. And basically what you're going to do is you're going to show that the result is you just get the function x. Okay? And so the way you do that is you just put one inside the other. Okay? Next one. Consider the functions 2x plus 5 and 8 minus x divided by 2. Find the inverse function of g and put -1 in for x. So let's find the inverse function for g first. Again, we use variable interchange, so we're going to have x equals 8 minus y divided by 2, and we're going to solve for y. So we're going to multiply both sides by 2, and then we're going to solve for y. Okay? And so here's our inverse function. And then we're just going to plug -1 in. And we're going to get 8 plus 2, which is 10. Okay. B. Show that the inverse function of f with -3 in it minus the inverse function of g with 6 in it is equal to 0. Okay, so let's find the inverse function of f. So we'll get y equals 2x plus 5, and then we're going to invert the variable interchange. You guys are getting good at this now, right? Getting good at your algebra too. X minus 5 divided by 2. Remember that what you found here is the inverse function of f. Okay? So, and back here you found the inverse function of g. Okay, and it says, okay, take the inverse function of f and plug in -3. So if you put -3 in for x here, you're going to get -8 divided by 2, which is equal to -4. So this would be -4. And then it says, find the inverse function of g with 6 plugged into it. So we're going to take the inverse function of g, which is y equals 8 minus 2x, and then we're going to plug in 6, and we're going to get 8 minus 12, which is -4. So that's also -4. And then so we're going to do a minus -4, and hey, we got 0. Okay? Alright. Now find x such that f follows inverse g of x equals 9. Yeesh. Okay, so first we're going to take g inverse function, which is that. Okay, and we're going to put 8 minus 2x. And then we're going to have it followed by function f. And function f, remember, is 2x plus 5. So 2x plus 5. And we're going to set that equal to 9 so that we can figure out what x makes that true. Now we just need to do algebra. So 16 minus 4x plus 5 equals 9. 4x equals 16 plus 5 is 21 minus 9, which is 12, equals 4x, x equals 3. Okay. 13. Consider the function 5 to the x and square root of x. Now you're going to find 2 plugged into f, 4 plugged into the inverse of g, the inverse function of g, and you're going to do that too. Okay, g inverse follows f of x equals 25, and you're going to find the x value. There, it's very similar to what we just did before. If you want to find the inverse function of g, then you just do variable interchange, right? You have like x equals square root of y, You're going to solve for y, so you square both sides, you get x squared equals y. Okay? Y equals x squared is the inverse function of g, and then you can proceed. Okay? 14. You have the f function, which is 2x. You have the g function, which is 4x minus 3. Show that, and they have inverse function of f follows inverse function of g. G follows f inverted. Okay? I think that this is maybe a little bit different than what you're used to. So you just find g follows f, you find a composite function, okay? And then you find the inverse function of that using variable interchange. And you show that those two are also the same. 15. Which of these functions is a self-inverse function? Okay, so basically, if you graph these, and then you see that they are symmetrical about the y equals x axis, y equals x line, then they are self-inverse functions. Okay? And if you need to, use the calculator to help you graph these. Last of all, 16. The horizontal line test says, for a function to have an inverse function, no horizontal line can cut its graph more than once. Explain why this is a valid test for the existence of an inverse function. Which of the following functions have an inverse function? Okay. So, remember that that like a function has the vertical line test, right? And remember also that the domain of a function is the range of its inverse function, and the range of a function is equal to the domain of the inverse function. Okay? And so that's kind of why the vertical line test becomes the horizontal line test, right? Because like you're basically turning the thing sideways. So what was the vertical line test before now becomes a horizontal line test. Okay? So let's take, that's the explanation for A. Now what about B? We are going to do horizontal line tests on these. And if the horizontal line test works, then we know that there is an inverse function. So yes, the horizontal line test is working. Every time you do the horizontal line test, you only cut it once. No, that doesn't work. So this doesn't have an inverse function. No. Yes. What about this one? No, also no. Okay? And I think that's it.